which filters the data more accurately. And after applying the Butterworth low pass filter, you have to find the peak values, and the peak values are also plotted as a separate graph. And then after finding the peak values, we have to combine the filtered data into a feature matrix, which helps in labeling the data. And after labeling the data, we have tried machine learning algorithms called support vector machines using tenfold cross validation, and also trained the classified boosted tree algorithm. And comparing the both accuracy of the both machine learning algorithm, we can apply this in the application which can determines the driver's driving behavior pattern, and intimates the driver about this pattern. The application development, the application development was developed using the MATLAB app, which we are still processing in the development process, and we'll just finish it within this month end. The result of this project is where the automotive industry uses machine learning algorithms and data analysis tools to improve the vehicle performance safety. And the machine learning algorithms like support vector machine identify the patterns in data and offers feedback to the driver user through a user-friendly interface system. Using the use of the smartphone sensors and machine learning algorithm is a promising solution to improve road safety. Then we come for our conclusion to our project, where in this research, the successful development of an algorithm is able to detect the driving pattern with a good amount of accuracy, with primary focus toward the compact SUV. The core of the algorithm is same for all types of vehicle, and to accommodate for other vehicle types is just a minor adjustment to the threshold limit. The technology can enhance driving habit and reduce collision on the road, and further research can contribute to creating a safer road environment to everyone. Thank you. Thank you, sir. That's our conference PPT, sir.
Thank you, Mr. Chandrachalan.
Sir, you have any questions, sir?
Yeah. Sir, Dr. Pradeep Kumar, sir, and Dr.
Hello.
Hi, Vijay. Hi, Dr. Pradeep.
Yeah, yes, it's a really useful project, and I just have few questions. So hope you could able to answer for that.
Yes, sir.
So you have mentioned that the F1 score is about 0.8 or something like that, right?
Yes, sir.
For
Point
of your
eight, sir.
system.
Yes, sir.
And how did you validate this accuracy?
Pardon, sir?
Now, how did you validate this accuracy?
How did we get this accuracy, or how did you validate means
Yeah, how you validate this? How you validate it? How can you say that this is the F1 score, which is the best one, or whatever it is? How do you validate it?
So we have, after training the model, we have gained the accuracy using the summing of predicted test and normal raw data, and after finding the accuracy, we have called the precision method, we have just used the precision of 1,1, and also the recall of 1,1, after the using the F1 score algorithm, we have multiplied 2 times the precision recall divided by precision recall plus recall alone. By using this algorithm, we can find the F1 score of our trained algorithm. So after finding that our algorithm is around 0.8, the average F1 score of this MATLAB algorithm was actually used for 0.6 to 1. So our F1 score comes under 0.8. So we validated this as average accuracy.
Okay, so that's what my question. Okay, so this is how you validate, right?
Yes, sir.
So okay, now how do you actually you have created some, you have collected some data, right?
Yes, sir.
So how do you think that your the driving pattern recognition system that could be applied in the real world scenarios? Okay, so you have developed something, but how do you think that this can be applied in the real world scenario? So just like for improving the driver safety or optimizing the vehicle performance. So how do you do it? Is it possible to apply this in the real world scenarios?
Yes, sir. It's like very easy to apply in the
Actually,
real life scenario.
right now, what we have is like the only the cameras are placed in all the traffics and all that, right? So only thing is the speed limit is captured. Am I right?
Yes,
So only
the
the speed
cameras
limit
and the
is
speed
captured.
limits are captured by the government of our in Tamil Nadu constitution. But what we are like we are going to develop is like where you can apply this in your mobile phone or in the cars like vehicles infotainment system, where you can connect the mobile into the infotainment system, which gives the alert to the driver like in front of the dash cam, like you are driving in a harsh manner. Please drive a regular manner, like that you can give a notification in the driver's dashboard, so it will be helpful
Okay,
where
sure. This is like so. This is to monitor ourselves, isn't it?
yeah, this is to
So.
monitor ourselves, or where like you
Mhm.
can also sometimes you would have give your vehicle to a driver or like in a valet parking, suppose like if the driver drives it harshly, you can like the vehicle's owner can also get the notification like the driver is driving the vehicle in a harsh manner, so it will be alert for both the
Mhm.
driver and then the owner.
Okay, so could you discuss any future directions or like kind of an extension of this particular work, which is like exploring the additional driving patterns or incorporating any other data types? I think you have selected the three data sources, right?
Yes, sir. Like
So is it possible to incorporate any other data source into it?
yes, sir. We can also incorporate with gyroscope and camera, which can be used to detect distracted driving, because the person may be driving in a normal manner, but the accelerometer sensor can detect only the change in acceleration. But if you use gyroscope and camera, we can detect the distracted driving, like where it can monitor the driver's eye movement and head position. The system can identify whether the driver is paying attention or not, and then also alert them accordingly. So and also the microphones can be used to detect aggressive driving, like someone if the driver is speaking harsh or like in the phone call, their driving patterns may change. So the incorporating devices like
But
GPS
whatever,
sensor.
yeah, I agree with you. But whatever you have just mentioned, don't you think that it is already available in like most of the sophisticated cars, like like you say, like Mercedes Benz and
Yeah, it's
Volvo, they
available, sir,
have
but
already.
it's available in the Mercedes and like BMW or in the Teslas, but it's not feasible for the common people to access. We the
Mhm.
machine we like algorithm we are developing, it's just a matter of smartphone where you can take along with you, but everyone cannot afford Mercedes Benz or BMW for this safety
Oh,
feature.
no, I'm just giving you an example of that, but I think nowadays the normal cars itself, like it comes with all these features, right? So, but anyhow, it's a nice idea, nice effort that like
Yes, sir.
anyone, like instead of depending on any other system, if
Yes,
the
sir.
system is not there, then probably you can have it by yourself uh, by just having through this app. So, but yeah, it's really good presentation. Thank you very much.
Yes, sir. Thank you, sir.
Thank you. Sir, Dr. Narayan Sami, sir. Sir, sir, Dr. Narayan Sami, sir.
Yes, sir. Yes, sir.
Sir.
I have one question. Are you implemented this project?
Yes, sir. We have implemented in our institution's test vehicle, sir.
Okay. Is there any issues or problems
We
in
have got the problems
implementation
during the application
implementation
development, sir.
stage?
Yes, sir. In the implementation stage, we have got the problems, but it's not under the algorithms. We don't get any issue in the algorithm. But when we try to develop an application, we got many issues in transferring the data through the cloud data. So we are
Okay.
still processing with these problems, and we hope we'll find the solutions for that.
I think this is the extension of your project.
Yes, sir.
A nice project.
Thank you, sir.
Thank you, Mr. Sandeep Cholan.
Thank you, sir.
Sir, kindly send that PPT to that mail.
Yes, sir. Will send, sir.
Thank you, thank you, thank you.
Thank you, sir.
Next, Mr. Dina Dayalan.
So, is it over, sir? Can we leave?
Yeah, yes, I can leave, no problem. Thank you. Thank you for your presentation.
Sorry, sir.
Mr. Dina Dayalan, are you ready?
Yes, sir.
Okay. You can share your PPT.
Sir, it will be so.
Yeah, it's showing. But just maximize your screen. Are you presenting in your mobile phone?
It will be so no format.
Just keep us landscape mode. Yeah.
Sir, it will be so clearly.
Yeah, not it, sir. So, Dr. Pradeep Master, Dr. Narayan
Okay.
sir, is it okay?
Visible, sir?
Okay, sir, no problem.
Okay, no.
Yeah, it's
Okay, Mr. Vinod. You can proceed.
Hello everyone, I'm Dean Dalan. This is my project title Design and Analysis of Water Brake Disc for Light Moving Vehicle with Stainless Steel and Aluminum Metal Matrix Composite. I'm Dean Dalan, guided by Vinod Raja sir, my HOD. Objectives: mostly brake discs are made up of grey castan because it was more availability. Grey castan brake discs have drawbacks such as scoring, cracking, rusting, bulging. The problem can be minimized if the better material grey castan is used to rotor brake disc. In the project, stainless steel and aluminum metal matrix composite material are used to rotor brake discs for light moving vehicles. Modeling also used for SolidWorks, analysis for ANSYS Workbench 18.1. The results are compared between performance material for the rotor brake disc. Introduction. All the vehicles should have braking component because it was more important of safety. The vehicle stopping and reduce the speed is used to our brake system. The braking components have caliper, piston, brake pads, and brake disc. When drives apply the pressure in the brake pedal, it makes the piston to pressure against the hydraulic fluid that makes the brake pads to force against to the rotating brake disc. This is create the ions fraction of the rotating motion, so the vehicle will be stopped or slow down. There are different types of brakes are available: hydraulic brakes, electric brakes, mechanical brakes, and more extras. Rotor brake disc is important part of brake system. This project helps to improve the performance of rotor and reduce the drawbacks. Mid-size luxury cars brake disc, which is made up of grey castan, is used to model in this project. Grey castan rotating brake discs have drawbacks due to elevation of temperature and stress factors. This leads the brake disc to get damaged like scoring, cracking, wearing, rusting, bulging, etc. The problem can be neglected if we use better material in rotor brake disc. Material selection to it should be it should have high stiffness, high strength, and even elevated temperature, low density. Thermal conductivity should be high. Have excellent abrasion resistance. Must must have good grip resistance. Reason for choosing aluminum metal matrix composite and stainless steel. Aluminum metal matrix composite is high strength and elevated the temperature and high stiffness and low density. The high thermal conductivity and excellent abrasion resistance. 10% of silicon carbide is used to reinforcement. Stainless steel have properties which have high corrosion resistance. It have high strength and hardness. The temperature because high chromium it has corrosion resistance property. It has 10.5% of chromium content by mass and 1.1 or 2% carbon by mass. Properties of material. Material properties density, Young's modulus, position ratio, Poisson ratio, specific heat, thermal expansion, thermal conductivity. Gray crystalline density is also 7200 and Young's modulus 125 compared to aluminum 10% of silicon carbide 99660. So the gray crystalline is better than aluminum metal matrix composite. Dimensions of the brake disc: outer diameter 256 mm, inner diameter 150.1 mm, height 48.3 mm, central hole 65 mm, number of bolt holes 9, contact area 2500 mm square. Calculation: first vehicle load is measured, and next P max and normal load of the disc, tangential load and total load. It will be measured again. Torque will be measured and assembly of velocity of the vehicle velocity 27.778 meter per second, and deceleration minus contact area is equal A is equal to 5.6 meter per second square, and braking time measured, braking energy measured, and braking power also been measured. The heat rise in temperature, the heat withstand the materials is measured. Gray cast iron 371.2 degrees Celsius, stainless steel 48.12 degrees Celsius, aluminum metal matrix 680.62 metal degrees Celsius. So aluminum metal matrix is better component to compare in gray cast iron. Modeling is SolidWorks 2015 model, and analysis of rotor brake disc. It has 497547 knots and 328304 elements. And one Mises stresses, gray cast iron and stainless steel and aluminum metal matrix, and total deformation, gray cast iron and stainless steel and aluminum metal matrix. Temperature distribution, gray cast iron, stainless steel, aluminum metal matrix. Total heat flux, gray cast iron, stainless steel and aluminum metal matrix. Finally, the results: gray cast iron equivalent stresses 1.2247 into 10 power minus 2 minutes. Total deformation 1.038 into 10 power minus 3 max. Aluminum metal matrix 5.4 and total deformation 4.4 and something. So the material choosing aluminum metal matrix is compared to gray cast iron is better than. So the material from the results is clearly show the aluminum metal matrix has lower deformation than other materials. So the deformations of rotor brake disc can be reduced when aluminum metal matrix is used. Equivalent stress is low in aluminum metal matrix compared with the stainless steel and gray cast iron, hence wearing of rotating brakes disc will be reduced when using aluminum metal matrix in rotor brake disc. Heat flux and temperature distribution is high in aluminum metal matrix so it can withstand high temperature when compared in other material. Due to this, cracking of brake disc can be minimized. The same uh, deformation gray casting and stainless steel is higher when compared to aluminum metal matrix. Equivalence test is lower aluminum metal matrix when compared in stainless steel and gray casting. Temperature distribution is total flux is high in aluminum metal matrix compared stainless steel and gray casting. Reference. Thank you, sir.
So it is a nice presentation. That's a question. So in which vehicle you used for this design of brake system?
Which vehicle, sir?
In which vehicle you take for example for this
Light
braking
moving
system?
vehicle, sir. Bike, so car, small size car,
Small size,
small size cars.
small size car.
Not
Where you
heavy
take the dimensions, sir?
dimensions, sir.
Yes.
Dimensions I'm taking net.
Uh, There you can apply it in the vehicle.
No, sir.
Just you analyzed in the
Um,
software only.
yes, sir.
Okay, then how can we predict the results?
Uh, I'm just analyzing the systems is set to inform the system results, sir. ANSYS results.
Sir, any other questions?
Yes, so Dena Dayalan, right?
Yes, sir.
Yeah, it's really nice presentation. I
Thank you,
just
sir.
want to know a few things, a few clarifications. Like, uh, I think you have mentioned like you're using 10 percentage of silicon carbide as a reinforcement, and what is the rationale behind using 10 percentage of silicon carbide as reinforcement in the rotor brake disc, and how does it affects the performance of the brake?
Silicon carbide is used to the fluxing. Uh, it will be high fluxing material, so I'm using the breaking this.
No, why particularly 10 percentage of silicon carbide? I say.
More silicon material will be fall. So
Okay, so okay, in your slides that I think you have mentioned, the von Mises stress and all. On what basis that you have calculated the von Mises stress?
using ANSYS material, see ANSYS software, sir.
No, I understand that, but what is the criteria of to follow that von Mises stress? What is the factor of safety that you have given,
Safety,
and what kind of forces that you have applied? Since it's a rotor disc, right? So, what kind of forces that you have applied on it?
forces, stresses, sir. Stresses and temperatures,
So yeah,
total
of course, when
deformation.
you model in the SolidWorks, you need to apply the load, right? So
Yes,
only after that, as a results, in the ANSYS, it provides you the one Mises stress, correct?
correct, sir.
And what are the forces that you have applied? On which particular area the forces were applied?
The area of blades,
Because if it is just like a tensile load, you can just apply a point load on both the hand. right? Just a point load on a both the hand. In that case, since it is a rotor disc, what type of forces are applied?
Of course.
But anyway, thank you. It's a very nice presentation. So
Thank you, sir.
yeah. Okay, sir. Thank you.
Thank you, sir. Next, Anand Saran.
Hello, Dina Dayanan.
Yes, sir.
Yes, sir.
I have one question.
Yes, sir.
Okay, sir.
How the composites are made? Is there a liquid metallurgy or a solid state processing?
Solid state process, sir.
Which one? Which process?
Aluminum metal matrix.
How the composites are produced?
Heat.
How the discs
Total
are
heat.
fabricated?
Sir. Sir, cannot hear.
How the composite disc? It is casting or powder metallurgy. What is the
Powder.
process? Powder?
Powder aluminum silicon composite.
Please check it there. It is liquid
Okay.
state or solid state. Please check it.
This is
Thank
powder
you.
state. How can I? Any other questions, sir?
Okay, thank you, Dina Dayalan. You can leave the meeting. Next, Anand Sharan.
Thank you, sir.
Yes, sir. Anand sir here, sir.
Okay, share your
Sir,
screen.
can I leave?
Yeah, yeah.
Yes, Dina Dayalan, you can leave.
Thank you, sir.
Anand Sharan, share your screen.
Sir, the screen visible for you, sir?
Yes.
Sir, is the screen visible, sir?
No. It's not visible.
Sir, is the screen visible, sir?
Not visible. Stop it. Okay. Okay, you can start your presentation.
Yes, sir. I'm Anand sir, from mechanical department, sir. Our project is a multi-objective optimization of FDM manufactured PLA using desirability approach, sir. Hello, sir. Yes, sir. Sir, our
You can
abstract.
continue.
Yeah, yes, sir. Abstract. We are using the PLA material, sir. That's called, also known as the polylactic acid. That we are comparing to the FDM, sir. That it is specially made by the FDM 3D printer, sir. And the material that we are using, sir, that are natural and are recycled materials, sir. And it's also eco-friendliness, biodegradable, sir. And it's all used in the manufacturing of bottles, containers, packaging materials, sir. Our research is to analyze that mechanical strength and the durability, and comparatively which sample is I think which kind of material is more stronger and durability. And we are checking that we are taking 9 types of samples, sir, by using the 3D printer machine. Also, that 9 type of material is, sir, Taguchi's L9, sir. There are different types of testing. Taguchi's L9, Taguchi's L17, and Taguchi's L27. We are choosing that Taguchi's L9, sir, and we are now we are introducing about the rapid prototyping, sir. The usage of that rapid prototyping in the all over world. in the flow chart that we are saying, that we are showing us this kind of things are where it is worldwide usage, sir. The pie chart, 32% in motor vehicles, 18% in consumer products, 11% in business machines, 9% in medicals, and 9% in academic, aerospace, government, military, and other. Sir. And now we are showing the workflow chart, sir. First, we are giving the surface solid model, generate a STL file, the processor from next to next step, the processor generate STL file, build supports if needed, from then it gets sliced, and build prototypes. The model can be built and remove support that extra, and clean the surface, post circuit and part computer, sir. These are the workings of that 3D printer machine, sir. And we are choosing now we are showing that additive manufacturing and subtractive manufacturing, and now we are choosing additive manufacturing, sir. The additive manufacture, we have fixed the material, that material in the 3D printer machine, sir. Then it will additive, which means that it will add the thing, and it gives us a material, sir. And subtractive manufacturing is a that it slices, means it drills the project and gives us the material, sir. These are the different types of additive and subtractive manufacturing, sir. Types of rapid prototyping: stereological solidification of photo curable, sir. Paul F. Jacobs in 1992, sir. Training. This is our fused deposition modeling, sir. The principle of that we are using modeling based on the surface chemistry, thermal energy layer, and technology. The material in the form of wire filament is melted in the head of the FDM machine with extracts of the base as per the model, and then the material is cooled and formed as a that RP, rapid prototyping system, sir. These are our working process, and this is the exact model, CAD model of our 3D printer machine, sir. That filament spool, there we fix the material, and then the extruder in between the extruder, the material will go, and the heater block that will heat the material, and heater nozzle will lay the material in, and build platform. There will be, it will build the model, sir, according to our CAD model, sir. The literature you said that you have research about these, right, and the mechanical properties and the desirabilities and durability, and the energy strength, and we have research about the author and journal publisher. And this is the material that we are choosing, sir. The polylactic acid, called as PLA, the thermoplastic monomer, and it is very renewable organic sources and made up of cornstarch, sugar cane, but it's completely eco-friendly, sir. And it is very, and the PLA production is very different from other plastics. So producing fossil fuels through the distillation of polymerization of petroleum, sir. And the applications are manufacturing aids. That way we are choosing the PLS means it's very high stiffness and useful for industrial manufacturing aids, domains, automobiles, and the parts are end-use parts, which means that have very strong and tough properties can be made with the PLA. And these are our applications: the drone parts, the wings of the drones, the main parts of the drones that are very less weight and more strong and durability, sir. And this is our machine parameters, sir. Build volume, the layer thickness, the printing speed, the nozzle diameter, filament diameter, layer resolutions, and max extruded temperature, sir. This is our machine, sir. This is a research objective. The present investigation will fulfill the need of industry with a new combination optimized parameters to fabricate PLA through FDM technology. The objectives the present of research includes evaluation of machine mechanical properties by using various experiments on flexural and surface roughness to the specimen. And the flexural and surface specimens through these Taguchi desirability approach, sir, that we are using, that Taguchi's L9 we are chosen. And these are the methodologies, sir, the project methodology. So literature survey, selection of method, we have select the material and CAD model, then 3D print and the samples we are given, and the flexural testing surface, and optimization parameters using DFA, and selection of the best combination that we have chosen and validate. Um, and this is our sample set. 9 different types of sample we have collected, we have made in the lab in the flexural testing, sir. And this is Taguchi's L9, sir. The 9 trials, the level 1, level 2, level 3, it goes. And we have parameters, sir, different parameters. Pattern, LT, cell count, sir, in the shapes of hexagon, triangle, square, sir. And the dimensions of the samples are also shown on the screen, sir. Yes, sir, this 9 experiments, that 3 patterns in the different LT and cell count, sir. And the 3 patterns are hexagon, triangle, and square, sir. And in the results, sir, the flexural strength of MPA is D790, and the flexural moles of MPA is also D790, sir. And these are our measurements, sir. The surface roughness measurements are carried according to the ASTM. The ASTM is also American Standard Testing Materials, sir. Standards at micro labs, and sir, it was done in the micro labs, Ambattur, Chennai, sir, that we have gone through and done the rule, sir. The RA value of samples are shown here, sir, and they're shown in the table, sir. Okay, thank you, sir. Our presentation is over. Sir?
Sir, nice presentation. That's one question. Normally, we are facing problems in 3D printer while fixing the uneven components.
Yes, sir.
How do you avoid this?
Sir,
How do you,
for that we are choosing a material selection with a good manner, and our materials are very biodegradable and in less weight and give more strength, sir. So there's no issue in using uneven compounds or materials.
my question is, while fixing the component, that is uneven components, normally the area of contact is more in the bed, that is no problem. If you are having any uneven surfaces, and also while removing the component, it is also one of the problem in the 3D printer. So any
Yes,
other
sir.
solutions?
Sir,
Anand Sharan,
Yeah, yes, sir.
are any other questions?
Yes, sir.
Dr.
Yes, Anand Saran, it's a nice presentation,
Thank
but
you,
it's
sir.
a latest trend. The 3D printing is, it's not like latest trend, it is already available, but now it is more like everywhere they are using, like 3D printing.
Yes, sir.
So more than the PLA and the other materials, nowadays they are moving forward towards the metal printing and even for the construction purpose and all that. Okay. I have few questions to you. Like, can you just give us some the factors and then the response that you have used for Taguchi L9 method?
Sir, we are
You have
using.
used yes.
Yes, sir. We have used the Taguchi's L9, sir, because of there's a lots of tests available. We have choose that Taguchi's. So in Taguchi's there are Taguchi's L9, Taguchi's L16, and Taguchi's
No,
L27.
my question is what is the factors and then the response of using L9 Taguchi method?
So using this in order to estimate the factors that influence the performance criteria and also with factors more important than others, sir.
Yeah, I know, but what are those factors I'm saying? What are the factors that you have considered for this L9?
Karan, it is available in your slide.
Yeah, yes, sir. I'm sorry, sir.
I think you have considered around three factors, right?
Yeah, yes, sir. Yes, sir. Three factors, sir.
Okay, so what is the main response? This is not the one, I think. But anyways, just
Sir,
I
the
think
fact,
yes, yeah.
sir, the factors that influence the performance criteria
Hmm.
and also with factors more important than others, sir. The analysis of mean of we use the ANOVA table, sir, is used in order to get objectives of this paper.
No, again, I think you did not get my question, I believe. So I just asked you what is the factors that you have considered for your L9, and you have already given in your slides. I remember, I think in your earlier slides. I think can you just pick your slide number 21?
Yeah, yes, sir. Yes, sir. So visible,
So
sir.
these are some of
Ah,
yes. So what are the factors now you have considered here?
sir, that hexagon, triangle, square, sir. The patterns, pattern, LT, cell count, sir.
Okay, so pattern is one of the factor, isn't it?
Yes, sir.
Okay, what is the response? You
Sir,
have measured, I think, only the surface roughness, right?
yeah, yes, sir.
Not any other testing. It is just only the surface roughness.
Yeah, yes, sir. The surface roughness and the durability and the strength of this specimen, sir.
Okay, so you have measured both durability and the strength.
Yeah, yes, sir.
Is it like tensile strength?
Yes, sir. Also tensile, flexural
Have you
tensile.
mentioned flexural? Okay, okay, fine. Okay, so you have mentioned some, I think you have used fused deposition modeling, right? So, and also you have mentioned some stereolithography. But how? the stereolithography differ from the FDM, fusion deposit modeling, in terms of the printing process and even the final product?
Sir, it's more efficiency, sir.
Which one is more efficiency?
FDM, fused deposition only.
Okay. So I think you have used PLA, right?
Yes, sir.
I think it
Clearly,
comes under the
49.
category of, yeah, it comes under the category of thermoplastic. But what are the other thermoplastics that can be printed by using 3D printer?
Sir, PVC, sir.
PVC. I think other than PLA, I think you can print even the PET, ABS, and nylon. These are some of the other materials that you can print, right? So
Yeah,
these are all the categories of thermoplastic, but this particular technology is available quite long time. Okay, but now it is like moving towards so many other 3D printing, like like photopolymers, and even the metals can be printed nowadays. They are trying to print through composites, the composite materials itself. They are trying to print through the 3D printing, like for example CFRP, the glass fiber reinforced plastics, like carbon fiber reinforced plastics. These are also the things that can be printed there, through 3D printing. And other than that, even ceramics, even the biomaterials also, they are trying to
uh,
print through the 3D
yes,
printing. Okay.
yes, sir.
So
Yes, sir.
like hydrogels, they use the collagens, and these are the materials they try to print for biomaterials. Okay.
Okay.
So okay, it's nice presentations. Like uh, hope you can do better.
Thank you, sir.
Okay. Yes, thank you.
Thank you, sir.
Dr. Narayanasamy sir.
Um, what about the infill percentage, printing speed, and the nozzle temperature? Are you consider these factors?
Okay, nice presentation. Anand Sharan, can leave the
Are you
meeting.
consider other factors like infill percentage, speed, and nozzle temperature? I hope I am audible.
No, sir. No, sir.
Okay. Now I am audible.
Yeah, yes, sir. It's audible, sir.
What about the infill percentage, the printing speed, and nozzle temperature? These are the factors in a 3D printing machine. Are you consider these factors,
No, sir. No, sir.
or is it a constant one?
Yes, sir. Constant work, sir.
Okay, okay. Thank you.
Thank you, sir. Thank you, sir.
Next, James Peter Samuel. James Peter Samuel.
Sir, on request, sir,
Sir.
on request, please
Yes,
limit
sir.
the presentation time, sir.
Okay, sir.
Okay.
Yes.
James Peter Samuel.
Sir, can you see my screen?
Oh, I will share your screen.
Sir, is my screen visible, sir?
So it's not visible.
Sir, is my screen sharing, sir?
No, it is not sharing. Kindly share kindly press the press now button, then share your screen.
Sir, now, sir?
Yeah,
Sir, is my screen visible?
yeah, it is visible. Yeah, it is visible. You can start your presentation.
Am I audible, sir?
Yes, audible.
Good afternoon, everyone. Good afternoon, sir. We are happy to attend the International Conference on Advanced Material Science, ICAMS 2K23. We are from MIT Engineering College. Myself, James, my friends Jamal, Nyanraj, and Gokul. Under the guidance of Dr. M. Kirbagaran, sir, ME PhD, our title is Design and Fabrication of Hydro Turbine for Power Generation. Presentation outline. We are going to see the introduction, literature review, research gap, objective, methodology, results and discussion, conclusion and reference. Introduction. There are many ways to generate electricity. Electricity can be generated using both renewable and non-renewable resources. For this project, we aim to use renewable resource like rainwater for generating electricity. Usually, rainwater gets stored in the rainwater harvesting unit, but we aim to use this rainwater before it reaches the rainwater harvesting unit to generate electricity. Therefore, the main aim of our project is to produce renewable energy source from rainwater. Literature survey. Meenakshi International Journal of Mechanical Engineering and Technology in 2017. Major findings are by using Pelton wheel, low pressure wastewater collected from building and converted into electricity. Mohan Aditya, electricity generation in high-rise building from discharge wastewater. Discharge of grey water from building can be collected and stored for electricity generation by using turbine and alternator setup. Research gap. For the research gap, it is observed that generation of power from non-renewable sources of energy such as coal and petroleum fuels, etc., generates high emission that causes health hazards. And we also came to know that water flowing down from pipeline of buildings has more amount of hydropower that can be used. Objectives. The main objective of this project is to design and fabricate the hydro turbine that converts kinetic energy of flowing water into mechanical energy. To convert this mechanical energy into electrical energy by using alternator setup and to store this energy in a battery for later use. Methodology. Design drawings, design calculation, material selection and working principle. The concept designs and 3D modeling are done using software called Fusion 360. This CAD software is used for modeling the 3D diagram of Pelton wheel and its components. As you can see, the 2D diagrams hub and spring of Pelton wheel components.
This is the final 2D diagram for our project. This software is called AutoCAD. The nozzle diagrams, 3D diagrams and 2D diagrams. As you can see the full setup using the 3D software. So you can see the Pelton wheel, nozzle, plumber blocks, shaft connected with the machine type motor. Experimental works. After modeling and analyzing the project, we bought the necessary items such as shaft, plumber block, and machine type motor, wooden table, and pipe for required height. We also made the Pelton wheel compact enough to fit inside the pipe itself. By using clamps, nuts, and bolts, we clamped the plumber blocks, machine type motor in place. As you can see in the diagram, the pipe is connected between two plumber blocks clamped in the wooden board. Inside this pipe, we have a Pelton wheel. Design calculation. For the design calculation, we use the formula to determine the sectional area of the pipe. Area is equal to 0.031415 meter square. Material selection. Selecting the right material for the right use improves the quality of the product. For the pipe, we use PVC material. For Pelton wheel, mild steel. For shaft, we use stainless steel. And nozzle, we select PVC material. Working principle. The rainwater from high-rise building, apartments, school buildings are sent through a pipe. On top of pipe, we have a filter which is used to clean the dust and unwanted particles. Inside the pipe, we have nozzle used to increase the velocity of flowing water. Below the nozzle, we have a pipe which converts energy of flowing water into rotary energy. This rotary energy is converted into electrical energy using alternator setup. Results. This project aims to create electricity from wastewater and rainwater collected from high-rise buildings. Once the system is set up, it can generate power continuously. There is relatively low it can be stored in a battery for later use. It is renewable and sustainable. Cost estimation. For cost estimation, the material cost approximately 2,000 rupees, manufacturing cost including machining cost and labor cost 1,000 rupees, total cost 3,000 rupees. Conclusion. The amount of rain received is connected in a high-rise building apartment produces sustainable energy that we can store for later use. By further improvement and development, continuous development, we can increase the efficiency and generate more electricity in rainy season. For the reference, we used in Wikimedia renewable energy and bright hub. Thank you, sir. Thank you, sir.
Thank you. Any questions, sir?
Yes, James Peter, it's nice presentation.
Thank you, sir.
Can you hear me? Yeah.
Yes, sir.
I just only have one or two questions. What steps did you really take to minimize the losses? I hope you must have calculated some losses, right? Mainly you will have some losses due to friction, right? The turbulence and all that. Whenever you talk about turbines, what steps did you take to minimize these losses? Losses due to friction or turbulence and any other factors?
So the losses due to friction mainly occur in the nozzle, sir. For that, we model the nozzle in the CAD software multiple times and multiple designs to get the maximum efficiency, sir.
Okay, so I think you have used some modeling software like Fusion 360, right? So why
Yes, sir.
particularly this software? Why don't you choose another software? There's a lot of softwares available, especially your project deals with the water and all that, right? So water
Yes, sir.
is there and then some fluid is there. In that case, Why don't you go
Yes,
for
sir.
some kind of SolidWorks where you can analyze those things, the fluid mechanics and all that, right? So you can compare those value, you can correlate with your
Yes, sir.
experimental results, and either you can go for an ANSYS workbench or something like where you can analyze the CFD through the CFD, and
Yes,
you
sir.
can correlate the results with your experimental results, right?
Yes, sir.
Maybe in the
We
future,
choose
probably you
the
can. Yes.
So we had an option to choose different CAD software, sir. But for students, it is the Fusion 360 software is available for free, and we can both CAD model it and we can analyze in the Fusion 360 software, sir.
Okay. So
So
have you
we,
tried to analyze?
yes, sir.
Have you tried to analyze some of this?
Yes, sir.
Some of the params.
We
Yes.
analyze the nozzle, sir, in Fusion 360,
Okay. So
and we
I think
continue
you have
to
not.
development.
Okay. I think you have not presented it, right?
Yes, sir.
Okay then. Okay. Thank you. All the best.
Thank you, sir. Thank you so much.
James, are
Sir,
you done any CFD analysis?
no, sir, not yet, sir. In future,
Why?
we will analyze it.
Is it not needed?
Sir, no, sir, we can analyze to get the more efficiency, sir. But we are still. I am not analyzed yet, sir.
Are you in third year or final year?
Third year, sir.
Okay, okay. You may extend your project in the final year also.
Yes. Thank you so much, sir.
Thank you.
Hello, Mr. Mohammed Asad.
Yes, sir.
Okay, okay. Thanks, Mr.
Sir, shall I cut the
Okay,
call?
Yeah, yes, sure.
Thank you, sir.
Okay. Hello, sir. Sir, shall we take a lunch, sir? Lunch break? Sir, excuse me, sir.
So may I know how many participants are still left?
Sir, 7 participants, sir.
Still 7 more participants.
Yeah, yes, sir.
Okay. Okay.
So next, as per schedule, 12:20 will come on one more participant, sir. Still no,
Okay.
not yet come, sir.
Okay. Okay. Fine.
Okay, sir.
Okay. Then can I leave for a while then?
Sir, yes, sir. We can rejoining at 1 p.m. Sir.
Okay. Okay. Thank you.
Thank you, sir. Thank you so much, sir.
Okay. Thank you very much.